Okay, we are now on part 2 of our prerequisite chapter. This section is focusing on geometry and the equations that have to do with geometry. My tablet here is dying, so if it's jittery, oh well. So we're going to talk about these geometric formulas that we need to know, and we'll end on circles. Before we get to those formulas, we do need to know absolute value. And absolute value is distance from zero. It's the magnitude or length of a segment. So if I have a point, say negative 14, and I want to know the magnitude of that, that's the absolute value, so we'd use these symbols, and that'd just be 14, and the absolute value of 14 is 14. When you have variables, this is a little bit tricky. What if I wanted to know the absolute value of x? Well, if x is negative, okay, it's a negative number, okay, then it's just going to be x. And if it's a positive number, still just x. So we want to make sure that this is a positive in the end. We can also do absolute value in 2 dimensions. That's a one-dimensional thing. But if I have a point right here, and I want to know the absolute value of that point, what I'm really talking about is the length of this segment right here. And that would also be called the magnitude. And the length of this segment could be found a variety of different ways. I could complete this right triangle and use Pythagorean's theorem to find the hypotenuse. Or I could use the distance formula, which we'll talk about a little bit later. Alright, so distance in 1 dimension. So what we're talking about here is if I have like a number line and I have 2 points on this number line. Maybe negative 3 right here and maybe 2 right here. Now we can count this pretty easily. 1, 2, 3, 4, 5. We have 5 units there, but if these are larger numbers, then we're not going to want to do that. So distance in 1 dimension, I'm basically going to take the first point, our x1 point, subtract our second point, our x2 point, and then I'm going to make sure I have the absolute value of that. So in this case, negative 3 minus 2. Do everything in the absolute value symbols first. So I get negative 5. The absolute value, that's 5. So I get the distance of 5. Now we could also make this look more like the distance formula that we're about to do, which would be square root, and then I could do x1 minus x2 squared, and then square root it. This way is a little bit faster, but this way it's going to give us the same answer. So just to show that. This way is harder, but it will look a lot more like the distance in 2 dimensions. But this is faster. Absolute value, subtracted points, and just make sure you have a positive, because our distances are going to be positive. Now suppose I know the distance in 1 dimension. Like maybe here's negative 4. And suppose I say the distance is 6. And this is one of my points. We'll say x1 is this. So x1 is negative 4, and my distance is 6. Well then, what's x2? Well, I have a total distance of 6. So that would mean 6 units to the right of this 4. So 1, 2, 3, 4, 5, 6. So that would give me this point right here. I believe that's a 2. 1, 2, 3, 4, yep. This is 0. So this is 2. So x2 could be 2. Or I actually could go the other way. It could also be negative 10. Those are my 2 options. But how do we get these algebraically? Well, our distance formula for 1 dimension, let's go ahead and use that other one. x1 minus x2 squared. The distance we want is 6, so we put a 6 in here. We know x1 is negative 4. To undo a radical, we square, so we square both sides. And now we expand that out. So that would be negative 4 minus x1 times negative 4 minus x1. We multiply that out, this times both of those. So we get 16 plus 4x plus 4x plus x squared. And we'll put those in the right order. So we have x squared plus 8x plus 16. Now we need to get everything to one side because this is a quadratic. And we get a negative 20. Doing this in my head, so I don't know. And then we factor that. X minus 2, x plus 10. So we could get x equals 2 or x equals negative 10. That's one way to do it, distance formula. We also have the absolute value distance formula, so let's go ahead and take a look at doing it that way. So distance in one dimension, x1 minus x2 in absolute value symbols. Take that 6. This way, again, a little bit easier. X1 is negative 4. Alright, so now with absolute value, I have two possibilities. It could be negative 6, or it could be positive 6. I could add that 4. And this is a negative, so switch that sign. Add that 4. This is negative, so switch the sign. 10. Okay, let's do 2 more of each of these cases, and then we'll see. Let's say my points are negative 15 and negative 90. Okay, what's the distance? Well, distance, we'll use the absolute value one, is x1 minus x2 in absolute value. So negative 15 minus negative 90, negative 15 plus 90, which is 75, pretty sure. Alright, so that's that one. Pretty simple there. But what if x1 equals 18 and distance is, let's say, 12? What is x2? What's the other point? So I could have, if I think of my number line, if this is 18, I could have some point over here, that's x2, that has a distance of 12, and I could also have a point over here that is also a distance of 12. So distance is absolute value of x1 minus x2. My distance is 12. x1 is 18, x2, I don't know what it is. Now it really doesn't matter which you choose as x1 and x2. I could just as easily, and why don't we just emphasize that? Let's say I switch those around. It makes no difference, really. Alright, so this could be positive or negative. So negative equals x, we'll say x2 minus 18, that should be a 2. And 12, x2 minus 18. Then we add the 18 to both sides, so I have 30 is x2, one possibility, add the 18 here. And we get 6. So that gives us our 2 points, 30 and 6 give us a distance of 12 from the point 18. Alright, distance in 2 dimensions. So we have a formula for this. It's based on Pythagorean's theorem. Discussion we can have later, but it's this. x1 minus x2, we take our x coordinates, square them, and then we add it to the difference of our y coordinates. Again, the order of these does not matter. It's just important that you stay consistent. So if I have a point, say 4, 2, and 8, negative 3, and I want to know the distance. Okay, well here's x1, here's x2, here's y1, here's y2, and notice it's staying consistent. This is the 1 point, this is the second point. So distance equals square root, and then I'm going to do 4 minus 8 squared plus, okay, in all these formulas that it I'll say it, but it should go without saying. All formulas in PreCalc you basically need to memorize. You need to know all of this stuff from memory, be able to pull it out whenever you need it. So y1 minus y2, so I'll get a plus right there. And that's going to be a -4, and -4 squared is 16. And we get 25. And then we have 41, root 41. And we can leave it like that, and if the directions say to get an estimate or to round, then you go ahead and put this in your calculator and get our decimal. I'll do one more. Suppose our points are -4, -10, and 3, -2. I want the distance, so again, x1, y1, x2, y2. So we're going to do -4 minus 3 squared plus -10 plus 2 squared. So we get 49 plus 64, and we get root 113. And simplifying radicals does apply. So for example, if I got root 27, you would need to prime factorize that, split it up, and write it as 3 root 3. Yeah, that should be good. You may need this for other applications. We'll take a look at circles in a moment where we'll need that. Alright, midpoint in one dimension. I'm not going to talk too much about this as much as I did the distance, but it is basically an average of 2 points. So I take my first point, add it to my second point, and divide by 2. And that gives me the average, the middle of them. So we can see the middle of 4 and 6 should be 5. So that's going to be 4 plus 6 divided by 2, which is 10, divided by 2, which is 5. So pretty simple there. So if we had, say, -12 and 11, and I wanted the midpoint of those, I'd do -12 plus 11 divided by 2, and that's going to be -1/2, and that's fine to leave it like that. Now we might get a tricky problem where like the midpoint is given. So say the midpoint is 3 and x1, maybe that's 1. What then is x2? So we can take a look at the number line here and we say, alright, well x1 is at 1 and the midpoint, so here's 2, here's 3, so here's my midpoint. So what should x2 be? Well, we can see here by counting that is 5 pretty simply, but we can use our formula too if we had harder points. So midpoint is x1 plus x2 divided by 2. I know my midpoint's 3, x1 is 1, x2 I don't know, and whenever we have fractions we clear them, so we multiply both sides by 2, we get 6 equals 1 plus x2, and subtract that 1, we get 5 equals x2. Let's try that without a drawing. Let's say our midpoint is -6. Let's say x2 is -1. What's x1? Alright, well our midpoint formula in one dimension is x1 plus x2 divided by 2, and we just plug these in. So midpoint is -6, and then we have x1 plus -1 divided by 2. We clear our fraction, multiply both sides by by 2, we get -12 equals x1. Plus minus is minus. We add the 1, so I get -11 as our other point. Alright, in 2 dimensions, pretty easy, just an extension of the one we just did, except we do have an ordered pair. So we have x1 plus x2 divided by 2 like we just had, comma, y1 plus y2 divided by 2, because now we're in 2 dimensions. And it's going to work basically the same way as in 1 dimension. So if I had the ordered pair -4, 2, and 7, 9, and I wanted to know the midpoint of the segment that connects those, I'm just going to plug those into this formula. So our midpoint is -4 plus 7 divided by 2, and 2 plus 9 divided by 2, and we get 3 halves and 11 halves, and that's our midpoint. Do not drop the parentheses. This is an ordered pair, so we need the parentheses there as part of this. We could do this if I know the midpoint. Let's say the midpoint is 3, 8. And let's say our first point, so one of our points is 1, 2. Well then, what's the other point? What's on the other end? Alright, so we still have the midpoint formula, and the midpoint formula is this. So I'll plug in what I know, and I'll do it in 2 pieces. So I'll do the x piece and the y piece. So x1 is 1 plus something, x2 divided by 2, and y1 is 2 plus y2, don't know what that is, divided by 2. And I know in the end I should get 3 and 8, so I know that 1 plus x2 divided by 2, I should get 8, and I know here that I should get, oops, my bonobo, should get 3 x's, and for the y's 8. Clear our fraction, and subtract the 2. So y2 is 14, multiplied by 2, subtract the 1, get 5. So I get the point 5, 14 as the other thing, and that leads to this being the midpoint. And it's the same as in one dimension, I just have 2 different pieces that I need to account for. Alright, Pythagorean's theorem has to do with right triangles, so only right triangles. If you don't have a right angle, then Pythagorean's theorem is not going to apply. Now you can use Pythagorean's theorem to see if a triangle is indeed right or not. So let's say I have a 7, let's say a 5 right here, and I don't know what that is. Now Pythagorean's theorem says that the legs, the sum of the squares of the legs, equals the square of the hypotenuse. These 2 things, just so that we're talking about these in the right way, are called the legs of the right triangle, and this is the hypotenuse. Alright, so we'll plug in the numbers that we have here. X squared plus 5 squared equals 7 squared, and we follow the order of operations, and we subtract the 25, and then we take the square root. And again, radicals. See, a very common mistake in PreCalc for students is to think that they're done when they're not. We need to go ahead and prime factorize that and continue to simplify. So the square root of 2 squared is 2, and now we have it. This is our answer. That is the leg that was missing. Let's say we had, oh, I guess that's going to go away. Oh well. Let's say I don't know this. Okay, so again, a squared plus b squared equals c squared. So we have 6 squared plus 9 squared equals x squared. 36 plus 81. The cat's gonna kill me. I'm okay with that. Alright, and square root 127. We could try to prime factorize this. I don't think we get anything there, so I'm not going to bother. So that's Pythagorean's theorem. We can use it to verify if a triangle is right or not, so let's try that. So this one probably won't be, because I'm just making up the numbers randomly here. So 12, 5, 9. Okay. So I don't know if this is a right triangle or not. If a triangle is right, then Pythag works. So I pretend it is a right triangle, and I say 5 squared plus 9 squared. I ask a question, does that equal 12 squared? Well, 12 squared is 144, and that's 25, and this is 81, and when I add those, I see nope. So no, this is not a right triangle. And if it works, Did I miss add? If it works, then it is a right triangle. Okay, now I'm going to use the next thing. Before we get to circles, I'm going to use the next thing to do an example of something. I could have, say, a triangle right here. And I want to know the distances between these points. I might want to know the midpoint between these points. So I just need to find what these points are and do exactly what we did over here in the case of midpoint, and do exactly right here what we did for distance. I will just need to do it 3 times, 1 for each segment. Okay, circles. The work form of a circle is going to be x minus h squared plus y minus k squared equals r squared, where h, k, is the center and r is the radius. So if I had the circle x minus 3 squared plus y plus 2 squared equals 25, then my center is 3, negative 2. Notice different in sign than it is here. That's because of these minuses. And the radius is 5. We could also draw that right there.